I see you caught me practicing techniques for evaluating limits. You may be wondering, what exactly are techniques for evaluating limits? Well, don't worry. That will be covered and much more in today's project. We will also learn techniques for evaluating indeterminate forms using algebraic steps such as direct substitution, factor and simplify, rationalization, and common denominator. So, I want you to just sit back and relax and let Will, Nick, and I be your one study guide for limits for the final. Now, without further ado, let's go into the mind of a calculus student.
Hello, children. Welcome to the mind of a calculus student. The techniques to evaluate limits are vital to calculus because without them, it would be impossible to evaluate limits where undefined areas occur. So, to evaluate limits, we will start with the most basic technique to evaluate them, which is direct substitution. So, in direct substitution, we have here the example for the limit as y approaches 2 of y squared plus 5y plus 6 over y plus 2. And all you do for direct substitution is plug 2 in for any place where there's a y. And we get 2 squared plus 5 times 2 plus 6 over 2 plus 2. Calculate that out, and we get 5. And a very happy, angry, smiley face. All right. And that's the basic technique of direct substitution. All right, so the next technique to evaluate limits is factoring and simplifying. So as we move on, here's our example. As x approaches 2 for the limit x squared minus 3x plus 2 over x squared minus 4, we try direct substitution, which we just did, and we plug in 2 for anywhere where there's an x, and we end up with the indeterminate form of 0 over 0, which is no good. So moving on, factor and simplifying, we have our original problem still right here, and we factor that, and that factors out to, as x approaches 2 for the limit of then x minus 2 times x minus 1 over x minus 2 times x plus 2. And this is where simplifying comes into play. These two cancel out, and we are left with that, which is more clearly written here. As x approaches 2 of the limit x minus 1 over x plus 2. At this point, we can now use direct substitution. And when we direct sub, we put in 2 for anywhere there's an x, and we get the answer of 1/4, which is a much better answer. Welcome back. Our next technique used to evaluate limits is getting the common denominator. So we shall use the example as x approaches 0 for the limit 1 over x plus 2 minus 1/2 all over x. We again use our first technique, which is again the most basic, direct substitution, just to see if it'll work. And as we plug in 0 for any x's, we find that we end up with the indeterminate form, which again is no good. So we go back to our original problem, which is located here, and we multiply this side by 2 over 2 and the 1/2 by x plus 2 over x plus 2 to get the common denominator on top. Common denominator, which is 2x plus 4, and this is what we end up with on top, which cancels, the 2's cancel here and here, so we're left with a negative x over 2x plus 4 all over x. So since we're dividing by x, we'll multiply by the reciprocal 1 over x. So this negative x and this x cancel, but we must remain with the negative. So as we go on, we still now have the, as x approaches 0 of the limit negative 1 over 2x plus 4. And at this point, we go back to our first technique, direct substitution, and as we substitute in 0 for the x, we end up with negative 1/4, which is good. Welcome back again. We will now show you the third technique to evaluate limits, which is rationalizing. So we have our example here. As x approaches 0 of the limit x over the square root of x plus 4 minus 2. We again start with the most basic technique, direct substitution. And as we replace all the x's with zeros, we find that we get the indeterminate form 0 over 0, which everyone knows is no good. So as we move on, we come back to our original problem here, which is as x approaches 0, the limit of x over the square root of x plus 4 minus 2. We want to rationalize this, so we are going to multiply this by the square root of x plus 4 plus 2 all over the square root of x plus 4 plus 2. So this will get rid of the bottom square root, as seen here. We are just left with these terms, which these 4's cancel, and the x's cancel, which still look like x's, and we are left with, as x approaches 0, for the limit of the square root of x plus 4 plus 2. So again, we have our problem as x approaches 0 of the limit of the square root of x plus 4 plus 2. We use direct substitution, and as we plug in 0 for anywhere there's an x, we get it to be 4, which is good, because that's the answer. The next technique we'll run you through for how to evaluate limits is by using the properties of finite limits. And I'll just run you through what the properties of limits are for finite limits. So you just first need to start off by knowing that for the limit as x approaches c of f of x, that will equal L, and for the limit as x approaches c of g of x, that will equal m. So the first rule we'll start with is the sum rule, and this says that as the limit as x approaches c for the limit of f of x plus g of x, that will equal L plus m. Would you look at that? It works. Now the second one is the difference rule, and seen here as x approaches c for the limit of f of x minus g of x. Would you look at that? It equals L minus m. The next rule we have is the product rule, and would you look at that? As the limit, as x approaches c for the limit of f of x times g of x, look at that, it equals L times m. Alright, would you look at this? We have the constant multiple rule. As x approaches c for the limit of k times f of x, would you look at that, it's k times L. And here for the quotient rule, our final rule, would you look at that? We have the limit as x approaches c of f of x over g of x. That equals, would you look at that, L over m. But wait, would you look at this? M cannot equal 0. So, and if you want another recap on all of these rules, they're located on page 58 of your Calculus Mathematics book. Welcome back again, class, and look at this. We have an example for you using the properties of finite limits to evaluate a limit, and you're going to first need these pieces of given information, which are as x approaches a for the limit of f of x, it equals 2, and for as x approaches a for the limit of g of x, it equals 7, and as x approaches a for the limit of p of x, that equals negative 2. Here we go. We have our example problem as x approaches a of the limit of 6 times g of x plus 2 times f of x minus 3 times p of x. And this equals, using the properties of limits, 6 times x as x approaches a of the limit of g of x plus 2 times as x approaches a of the limit of f of x minus 3 times as x approaches a of the limit of p of x. And that all equals, using our original numbers which were provided to you at the beginning, plugging those numbers back in for these three limits, 6 times 7 plus 2 times 2 minus 3 times negative 2. And when you give it everything you got, you get 42 plus 4 plus 6. And would you look at this? Would you look at this? It equals 52. Welcome back one final time, class, and now I will show you how to evaluate limits, infinite limits, using the properties of infinite limits. And again, these are the same as the finite limits, except it's when x approaches infinity and negative infinity. Okay, then. If you do want the properties of infinite limits, then you can find them on page 67. So, okay, let's get started. Here's our example problem. For the limit as x approaches infinity of 9x plus sine x all over x, using the properties of limits, we get, as x approaches infinity for the limit of 9 plus the limit as x approaches infinity of sine x over x, which is again shown right here. We then have them using the properties of infinite limits. We have this equaling 9, and the sine of x over x equals 0. So 9 plus 0 equals 0, and everyone's happy.
I hope you've enjoyed our presentation on the techniques for evaluating limits, and I'd like to wish you all good luck on the final. And remember, stay classy.